All right, welcome back. Now that we have a basic idea of how to build a machine learning model, how to split the data, and also how to use it to build linear models, for instance, right? We're going to also consider another linear regression problem over here, and then see how we can apply our concept so far in building a linear regression model. Okay, now in this scenario, we're going to have a data set which is going to help us predict a car's mileage. Okay, we're going to have some features, and based on those features or attributes, we want to see if we can predict a car's mileage. Okay, or that is MPG. Okay, so first thing first, I'm going to import the libraries that we're going to need in this kind of scenario. Okay, and I'm going to import those libraries over here. Okay, so let me zoom in so that you know what I'm going to do over here. So first, I'm going to import numpy as np, right? And I'm going to need linear regression, right? So I'm going to import linear regression. I'm going to import a linear regression, but in order for me to get linear regression, it's actually present in linear models, which is inside sklearn. Okay, so I'm going to do import. Actually, let me do from sklearn, right? From sklearn.linear underscore model, right? Then I do import linear regression. Okay, this is how I'm gonna do it. Now after that, I can import let me import matplotlib, right? You're going to need it later on. Matplotlib dot pyplot, okay, as plt. Okay, that's what I'm going to do, and then I'm going to also import seaborn. So I'm going to do import seaborn as SNS, and what else can I import? Train test split, right? So I'm going to use from sklearn, right? From sklearn dot model selection, model underscore selection, right? I'm going to import train underscore test, right? I'm going to import this train test split over there, and I'm going to do %matplotlib inline. Okay, so that I'll be able to plot all the interactive visualizations inside the notebook. Okay, I'll be able to plot it inside this notebook over here. Okay, I think so far that is it, right? So let me run this one over here. Everything works fine. Now I'm going to load the data, right? Later on, if I need any libraries, I'll come back to do it, right? Right now, let me go, and then I'm going to load my data. Right now, we're going to use this MPG data, auto MPG. So I have it over here, but I've loaded it on the platform for you, so you can also load it and then practice along. Okay. I think I will need pandas to load this, so I'm going to do import pandas as pd, right? That's it. All right, so let me do this pd.read underscore, it's a csv file, so I'm going to do pd.read underscore csv, and I can pass in the path over here, right? So let me copy the path and put it over here, and let me store it in a variable, right? I'm just gonna call it c data over here, right? That is car data, nothing but car data, right? You can just name it whatever that you want. Okay, now let me run that. Name pd is not defined. I need to rerun this one again. Okay, great. Then I'll run this again. Great, now everything works fine. Now let's see what we have inside our c data over here, right? So I'm going to do .head, right? Remember I told you to have a peek at your data, right? So I'm going to see the first 10, right? Let's see the first 10 records. Great, so this is what we have over here. So we have the MPG, that's what we want to predict, right? We want to base on these other factors over here, right? Other features over here, and then predict the car's MPG. Okay, so we have the car cylinder, the displacement, the horsepower, the weight, the acceleration, the model year, right? And then origin, and we also have the car name. Okay, now for the description of the headings, right? Let me even put this one over here, right? For the description of the headings, we have mpgs, this is the miles per gallon. Then we have the cylinder, the displacement, right, which is measured in cubic inches. And then we have the horsepower, we have the vehicle weight, right, and then we have the time to accelerate, from which ranges from 0 to 60 mph per second, right, over there. Yes, that is the acceleration part, right. And the model year, right, and the origin of the car. So if you see the origin of the car column, right, if you see 1, it means America, right, it means that the car came from America. If you see 2, it means the car came from Europe. If you see 3, it means the car came from Japan. Okay, so over here we have 1, 2, 3, right, over there, 1, 2, 3 over there in this particular column. Okay, and then we have the car labels also there, right, the car type or the car labels over there, right. So the particular car is here, right. For instance, we have Ford Torino over the AMC Rebel SST and things like that. Okay, so now remember we talked about predator variables and we talked about target variables. Okay, so in this case, our target variable is the mpg, and all these are going to be our predator variables. Okay, all these are going to be our predator variables. We want to base on these ones to predict the car's mpg. Okay, you can also call this one as dependent variable, and you can call these ones as independent variables. Okay, all these ones to be independent variables. Okay, so we want to base on these ones and then be able to predict the car's mpg. All right. Okay, now let's see some of the things that we can do over here, right. Now we can check the shape of what we have over here. Let me do this one over here, and then I can do C, right, C data dot shape, right. So if I do dot shape over here, let's see how many records and how many features we have. Now you can see that we have 398 records with 9 features over there, right. So we know that these ones are supposed to be 9, and then we have 398 records in here, right. It's quite a small data set. Later on you're going to see thousands of records over there, right. In this case we only have 398 records. Okay, now if you see the if you see this column, right, we are saying that if you see 1, it means that the car came from America, and if you see 2, it means that the car came from Europe, right, and if you see 3, it means that the car came from Japan, right. But if you want to feed this thing to a machine learning algorithm, it will not understand what 1 means or what 2 means or what 3 means. Okay, it's just going to treat it as an integer, just 1, 2, 3, right. It's just going to treat it like that, but that's not what it means, right. One in human intuition, we know that 1 means America, 2 means Europe, and then 3 means Japan. But the machine learning model doesn't know that, right. It will not understand that. So in that case, we need to find a way to make sure that our machine learning model is not going to treat these things as just an integer, but something that has meaning. Okay, so I'm going to put the original original meaning over there. Okay, let me show you what I mean by that. Now if I pick my C data, right, and I go into that particular column, which is the origin column, right, let me copy it from here, right. If I go into that origin column, what I'm going to do is that I'm going to replace, right, I'm going to replace the ones, going to replace those integers with their real meaning, right. For instance, I'm going to replace 1 with America, and I'm going to replace 2 with the European, then I'm going to replace 3 with the Japanese. Okay, that's what I'm going to do over here. Right, now I'm going to do this thing in the form of a dictionary, right, where 1 is going to be mapped with America. Okay, 1 is going to be mapped with America. Okay, let me even use small letters over here. Okay, then 2, right, 2 is going to be mapped with Europe, right. So I'm just gonna copy this one over here, then I put E over here, and the same way 3 is going to be mapped with Japan, right. So I'm just gonna do it like this, then I put this over here, right. Then okay, this is what I want to do. Okay, this is what I want to do. Now you can even replace this Japan with, say, Asia, right. Maybe to broadly represent Asia. Okay, Okay, you can also do that instead of maybe Japan. You can do it, but I mean it's okay to leave it to Japan. Okay, because that's even the meaning over there. Now, once I do that, that is going to be the new that's going to be the new origin for us. All right, so let me run this one and see. Great. Now, if I show you what we have, right? Let me show you what we have in our C, in our C data. Okay. Now, if I do C data and I run this one over here. Okay, now you can see that origin. Now we have America. Wherever there's one, there is going to be America, right? And if there's two, there is going to be Europe, right? And if there's three, there is going to be Asia. Let me do dot tail and see something over here, right? Let me do dot tail over there and see what happens. Okay, now you can see that wherever there was two, it has been replaced with Europe. Okay, in the same way, if there's any three, there is going to be replaced with Asia. Okay, so I mean that's what I want to do, so that our machine learning model will not confuse one with ordinary integer one. Okay, but in this case, one has a meaning. Okay, one has a meaning. All right. Now, one thing that I also want to do is dropping this car name. Right, the car name is not going to help us make any predictions over here. Okay, so I'm going to drop that part as well. So I'm going to do C data, right, dot drop, right, and I'm going to drop the car name. Okay, and I need to indicate where I am dropping it from, right? That is, I'm dropping it from the column. So I do axis equals 1 to show pandas that what I'm going to drop is actually in the column. Okay, and now when I do that, my my new C data is going to come without that car name. Okay, so let me run this one. Good. Now let me show you again what we have, right? If I do C data again for you to see. Great. Now you see that we have it up to origin, right? Earlier on we have it up to car name. We've been able to drop that part. Now we're going to base on these based on these columns, right? Based on these features to predict the car's mileage. Okay. All right, now let's see how we can deal with missing values, right? So now we don't know if there are any missing values in there or not. So the first thing that I'm going to do is to check, are there any missing values in there, right? So I'm going to do C data, right? C data dot is null, right? I'm going to use is null function over here and then run this, right? Which is going to be very confusing over here. So I'm going to do dot sum over here. Okay, now this one is telling me that there's no missing values in there, right? Now one thing that I can use to confirm if there are no missing values in there, right? If I just eyeball it over here, I can see that the MPG is a float data type, the cylinder is an integer, displacement is supposed to be float, horsepower is supposed to be integer, weight is supposed to be integer, acceleration is supposed to be float, model year is supposed to be integer, and then origin is supposed to be object. Okay, now I'm going to check the data type and see if everything is in order over here, right? If I find anything strange, then something else might be there, but Python is not able to identify it as a missing value. So I'm going to do cd.d types. Okay, then if I do that, now this is what I have. MPG is float, right? Let's see, MPG is float, that's correct. Cylinders is integer. Let's see, cylinders is integer, that's correct. Displacement is float, that's correct. Horsepower is object, that's bad. It's actually supposed to be integer. Okay, which means there's something in there which is making it look like an object, but it's actually supposed to be an integer. Okay, we will come back to it. Let's continue and see. Weight is integer. Let's see what weight is integer. Okay, Python is identify it correctly. Acceleration float. Let's see if it identified correctly. Yes, acceleration is supposed to be float. Model year int. Let's see if it is able to identify correctly. Yes. Origin is supposed to be object. That's fine. It's able to identify correctly. Now you see that there's a problem here with horsepower. Horsepower is supposed to be an integer, but Python is identifying it as an object, which is wrong. Okay. Now I'm going to do this one to be able to fish it out, what is actually happening over there. So what I'm going to do is that I'm going to go into my that horsepower column, right? So I'm going to go into that horsepower column, right? And I'm going to convert everything to a string and apply the isDigit function on it, right? So if there's it's going to just going to ask a question over there, right? It's going to go through all the the horsepower column and then ask the question, is this value a digit? If it's a digit, it's going to be output true, right? If it finds that this value is not a digit, then it's going to output false. Okay, so I'm just going to go through all the values in that particular column, right? Because you can see that there's a break here, so I can't see all the values to figure out what is actually wrong, but I can use the isDigit to go through all of the the records that we have in horsepower, right, to be able to fish it out. Now after I do that, I'm going to convert everything to a data frame over here, right? That's what I'm going to do, and I'm just going to store it in a variable called HP isDigit, right? It's just a fancy name I'm giving. You can give it any name that you want. All right, now let me run this one over here and see what I have. Everything is fine. Now what I'm going to do is that if I pick this isDigit over here, which I have taken, right, I'm going to pass in the horsepower, and what I'm going to do is that I'm going to find if by any chance it was able to find any false in there. Okay, if it was able to find any false in there, it means that that particular value was not a digit. Okay, so I'm going to do that, and let me run this one and see what I have. Okay, so in order to get this thing perfectly, I need to use the original data over here, right? I need to do something like this, and let me run it again. Great. Now you can see that now if you go to the horsepower column, you can see that there were question marks in there, right? So these are the things that is making that are making the horsepower column not appear as integer as it's supposed to be. Okay, so now that we have been able to fish it out, we need to now deal with it. Okay, and that's how you do it. When you get your data set, you can explore the data, see what is wrong in some of the features that you have, and then deal with that before you even proceed to the next. We continue with this, it's going to give us a problem later on. Okay, so now what I'm going to do is that I'm going to replace these question marks with NaN, which pandas is going to understand as missing values. Okay, because pandas will not understand question mark as a missing value. Okay, so when they were collecting the data, when the data was not available, they put question mark over there, okay, indicating that so they put a question mark over there. The same with other records as well. All right, so in order to be able to work with this, right, we need to translate this into a language that pandas understands. Okay, so this, right, and I'm going to replace every question mark over there with numpy, right, NaN. Okay, I'm going to do something like this. Okay, and that should reflect in our original data set. Okay, now when I do that, the next thing that I want to do is to check this thing again, right? Let me bring great. Now you can see that instead of the question marks, now we have NaN. Okay, now pandas understand this NaNs instead of the question mark. Now if we go and check if there are any null values in there, now it will be able to identify that yes, there are null values in there, right? So let me do that over here and you will see. Now you can see that it is now identifying 6 null values in horsepower. Okay, earlier on it was not recognizing the question marks as as null value, so it was not able to count any of them. But now that we have been able to replace it with NaNs, it's now able to count these NaNs. Okay, I should have put this one down here. Let me even get rid of it over here. Right, I should have put it over here. All right, and then run it. Yeah, okay, fine. Now they are just six, right? They are just six out of the 370 something. They are just six missing values, so I can just drop them. But I don't want to lose information, lose the data. Dropping a data point should be the last thing that you need to do, right? NANs with something, right? Possibly I would prefer to replace them with a median, right? With the median of that particular column. Okay, let me show you how I'm going to do that. Let me first see the median of each of the columns over here. So I'm going to do dot median, right? I'm going to check the median of all the columns. Okay, so these are the medians of all the columns. I have 23 for MPG, displacement 148.5, horsepower is 93.5. Okay, so that's what I'm going to use, right, to replace these six values, right? Okay, so now let's do the replacement over. So now let's replace the missing values with the median. So this is what I'm going to do. I'm going to do C data, right? And I'm going to select, let me zoom in. I'm going to select the horsepower and I'm going to fill the NA, right, with the median of the column. So I'm going to copy this one and then I'll put it over here, right? And then I do dot median, right, to get the median of that particular column, right? And that is going to be the new the new horsepower column over there. Okay, so I just use the fill NA, and inside that I calculated the median of that column over there, and that is going to be the new horsepower column. Okay, let me run this one and see. Great, everything works fine. Now if we check if there are any missing values in there again, right, let's see if I put this one over here and check if there are any missing. Now you can see that now horsepower is not having any missing values in there. Okay, if you want to check maybe using this one to see if you see the NANs, it's going to give you something weird over there. Let me try that and see. Okay, now you can see that we don't have any missing values in there in the horsepower. We've replaced that with 93.5, 93.5, 93.5, which was the median of that column, right? 93.5. When we calculated the median, the horsepower's median was 93.5. So all the missing values have been replaced with 93.5. Okay, just like that. Now if we check the data type again, let me go and then pick it from here. Okay, let's see if the data type is now in order or we need to do this explicitly, right? Sometimes you do this, but you have to, the data type will not change. You have to do it by hand. Now you can see that it's still object. Okay, now I'm going to convert it from object to float or integer, right? So let me see how I'm gonna do that. So I'm going to let me copy it from here, right, and then convert that. So I'm going to do this thing dot as type, right, and I'm going to convert it to float, right, float 64, and that is going to be the new horsepower column for me. Okay, let me see, I think I picked the wrong one. Let me actually do this one. I wanted to pick this one. I just pick the C data and then select the horsepower, right, but not the SDGate one. Okay, this is what I want. Okay, so in my C data I'm just selecting the horsepower and then I'm using the as type function to convert everything to a float 64, and that is going to be the new C data that we have. Okay, let me run this one and see. Okay, now everything works fine. Now let's check the data type again and see if it has now changed to from object to float. Okay, you can change it to an integer as well, right? Either of them is fine. Now you can see over here horsepower is now float. Okay, that's what we want. All right, now one more thing that we did not do over here, which we need to consider. If you see here, let me even go up here all the way to here. Okay, here we we say that the 1 represent America, the 2 represent Europe, and then the 3 represent Asia, right? And that's what we did to get these origins, right? However, we cannot feed this thing to a machine learning algorithm, right? It will not understand the object or the string type like this. Okay, we need to find a way to convert this thing to a numerical value. Okay, we need to find a way to convert it to a numerical value. Initially, it was a numerical value, but Python would have, the algorithm would have treated it as, as just an integer. Okay, now we want our algorithm to see this thing as a categorical values, right? As a categorical variable, right? Either America, Europe, or Asia. Okay, we want it to treat it like that. So what I'm going to do is that I'm going to do dummies over here. I'm going to create some dummy variables for that. Okay, so let me show you how I'm going to do that. So let me maybe do this. I should have done that one up here, but that's fine. I'm just going to copy this one and come all the way down, and I'm going to put it over here, right? So creating dummy variables, continuation, right? Continuation, all right? So if you see it over here, it means that we are continuing from where we stopped when we're creating the dummy variables. Okay, so now what I'm going to do is to use the get dummies function. Okay, so I'm going to do c data, right, to be equal to pd dot get underscore dummies, right? So we have get underscore dummies in pandas, right? And inside that, I need to now indicate, now you can see over here the parameters. You need to put your data there, prefix, and then prefix separator over there, dummy NA, and all that. You can see the explanation of whatever that you need to put over there. Okay, now let me show you what I'm doing so that you get to understand it better. Right, I'm going to put my C data over there, right? I'm going to apply it on my C data, and the column that I want to have effect on this is the origin column, right? That is where, if you see over here, that's where we have the America and Europe and Asia. Okay, that's where I want this effect over here, and show you what we have over in our data now, right? If I do this, now you can see what has happened over here, right? If you see here, we have origin America, origin Asia, and then origin Europe. Now each of the origins have been given separate column over there. Okay, what it is doing is that if the origin is America, we say that 1 represents America. So what it is doing over here is that if the origin is America, then it's going to mark it as 1, then the rest are going to be 0. If the origin is Asia, then it's going to mark Asia as 1, and the rest are going to be 0, right? Let me do it like this, right? If the origin is America, then it's going to mark America as 1, the rest are going to be 0, right? If the origin is Asia, then it's going to mark Asia as 1, and the rest of these ones are going to be 0. Okay, that's what is going to happen. If the origin is say Europe, then it's going to mark Europe as 1, and the rest of these ones are going to be 0. Okay, that's what it's actually going to do over here. Right now, by doing that, we will not have ranking in our data set. Initially, if you see what we're having here, right, if we had left it like this before we changed it, if we had left it like this, our model will see that, okay, 1 is lesser than 2 and 2 is lesser than 3, right? So if I should give importance, then I'll give importance to 3. But we cannot say that cars that are coming from, say, Japan are greater than cars that are coming from Europe, or cars that are coming from Europe are greater than America, or greater than Japan. That's not our concern here. That's not what we want to do. We don't want any ranking over here. Okay, we don't want any ranking over here. What we want is for the algorithm to identify that we have cars coming from different continents. Okay, cars that are coming from different continents, and that is what we are doing over here to prevent that kind of ranking. So we are giving each of the origins their own independent columns, right? And then if the car is coming from a particular origin, then it will be marked as 1, the rest will be 0. If the car is coming from, for instance, you can see over here, this car is coming from Europe. Okay, so you can see that all the rest are 0 and then Europe is 1, right? Here the car was coming from America, so that's why all the rest are 0, 0, like that. All right, So that's what we want to do. Now we have all the features or the columns to be numerical columns, right? We have all of them to be numerical columns. Now we can now feed this thing to a machine learning algorithm to build a model. Okay. Now we can also check. Finally, we can check the bivariate plot, right, of all the features that we have over here, right? Let's see how they are actually. We can use the correlation to see how they are correlated with each other, whether they have strong correlation among the features, right, or whether the features are having stronger correlation to the MPG, so that we'll be able to predict it very well. You can also do that, but I'm going to use the bivariate plot over here, which is nothing but using the pair plot over there. Okay, so what I'm going to do is that I'm going to select MPG, cylinder displacement, horsepower, weight, acceleration, and the model year. Okay, I'm going to select these ones and then use it to do this pair plot. Okay, so I'm going to do see data, right, and then I'm going to use the iLoc, right, that is index location over here, and I'm going to, inside that, I'm going to select all the records, but I need from feature 0 all the way to feature 7, right, so that I'll have the feature 6 inclusive. Okay, so it's going to be all the way from here to the last one, which is going to be 7 features over there. All right, and let me just store this one in a variable, so maybe I'll call it c data underscore, let me just do attribute, something like that. It's just okay for me. Okay, let me just show you what we have inside that one before I proceed to do the pair plot itself. Okay, let me run it. Okay, now you can see that I have it from MPG all the way to model year, right, all the way to model year. So that's what I'm going to use to do the pair plot over there. Right, let me get rid of it over here, and now I'm going to use seaborn, so sns.pair plot, right, and inside the pair plot I can put this the attributes that we've just selected, and I can indicate the kind of diagonal that I want. So I can do diag underscore kind, right, that's the kind of diagonal that I want, and I want it to be kernel density estimate, right, KD over here, right, which is going to be that smooth. Let me actually load it, you're going to see. Okay, great. Now you can see what we have over here, right? This is let me minimize it a bit, right? Now you can see the diagonals, right? This kind of a smooth curves over there, right? Kind of smooth over curves over there. If you don't want it, you can just leave it to the default. Okay, the default is going to come in the form of a histogram. Okay, so if I run it again, okay, now you can see how the diagonals are right now, right? You can see this form of a histogram over there. Okay, so you can use the KD like what I did earlier on, or you can leave it to the default, which is histogram, right? Mostly I prefer using the KD because that gives me the distribution of the attributes, right? It gives me a clear of the various attributes that I have. Okay, great. Now what we can observe over here, that we can see that some of the features are non-linear, right? You can see that it's not that, if you see this one is a linear relationship, right? The weight and displacement is having a linear relationship. You can draw a straight line to fit them, right? But this one, it's you can draw a straight line, but that won't capture most of the data points over there, right? If you draw a line like this, right, you draw a line or curve like this, right, this captures most of them over there, right? So you can see that some of them are non-linear, but there's a correlation over there, right, where some of them are negatively correlated. You can see that some of them too are positively correlated. You can see that some of them are highly positively correlated. Some are negatively correlated but not that strong. Some too do not have any correlation. Okay, you can see some of them too, they don't really have any correlation over there. All right, so this kind of gives you an idea of how your features are related over there. Okay, ideally you want the features to have a strong correlation with the MPG, right, instead of having a strong correlation with themselves. Okay, later on when we are dealing with multicollinearity concept, you get to understand why you need to prevent your data points being having high correlation with themselves. Okay, for now we will leave it like that, right, and then continue to build our model in the next session. Okay.